Hello everyone, my name is Pei Wang and I'm glad to present our work building and maintaining a third-party library supply chain for productive and secure SGX Enclave development. This is a collective research done by Baidu Security Research Lab. A little bit of background here. As we all know, a lot of concerns have emerged regarding the current practice of handling people's personal data by the big data industry. More and more regional government regulations have been deployed to restrict IT services providers how they collect, store, and manipulate large volume of private data. As such, people have been working on different solutions to privacy-preserving computation technologies. One of the major players in this computation is hardware-based trusted computing, with the root of trust embedded into CPU chips during hardware manufacture. Software vendors can encapsulate code handling sensitive data in the so-called secure enclaves. Secure enclaves encrypt the entire memory chunk with hardware provided keys, and data is decrypted only inside CPU packages. This allows enclaves to remotely prove their trustworthiness to users without relying on infrastructure software like OS and virtual machine managers. Intel SGX is one of the most mature trusted computing solutions on the market, and compared to competing solutions purely based on software like homomorphic encryption and federated learning, SGX secure enclaves are much more efficient. This is very cool, right? But hardware being secure doesn't mean things built on it are automatically secure as well. If the software code itself is vulnerable, and even if it runs in SGX, the data can still leak, like all the hardware protections are not there at all. This has been proved by previous research. And it is known that a large portion of severe software vulnerabilities are caused by memory safety bugs. A lot of things have been done to deal with these bugs, but they just refuse to die. So there's now a new idea that instead of cleaning up the mess after the bugs are there, how about preventing these bugs from being created in the first place? So one of the realizations of this idea is the Rust programming languages. And software written in Rust, thanks to its sophisticated type systems, they're immune to most memory safety vulnerabilities like use after free, buffer overflows, etc. So we realize that Intel SGX and Rust, when combined together, they can form a great solution to trustworthy private data processing. And developing the SGX Enclave in Rust has a beautiful property that if the code compiles, it should be secure and trusted. This idea is researched in our previous work. We have enabled memory-safe SGX Enclave development in Rust and provided formal guarantees for several important memory safety properties. However, modern software engineering is not about just writing your own code, right? Nowadays, all reasonably complex software has to depend on third-party libraries. And a question is naturally raised. Can Enclave developers rely on in-stock third-party Rust libraries? Are they compatible with SGX programming and security model? Based on our research, the answer is unfortunately no. SGX developers have to either import likely insecure third-party code or write everything from scratch. So they have to compromise either security or productivity. That's a problem we want to solve in this work. We want to build a supply chain of Rust libraries that are secure within the SGX thread model to boost Enclave development productivity. For this objective, we designed a protocol to examine and audit third-party Rust libraries and securely pour them into SGX. We built a highly automated framework to merge upstream changes to the ported versions of the libraries, keeping them up to date. And by the end of last year, we have ported 159 Rust libraries with this methodology. And this turned out to be extremely helpful to the SGX Rust community. Here's what we have achieved. By last October, we have ported the majority of the most popular open source Rust libraries into SGX and have kept them updated. So these libraries are all manually audited to make sure they do not break security requirements for SGX enclaves. And the majority of the work was done by a small team of 3 engineers, which is really impressive. So to understand how our work have been helpful, we searched the entire GitHub and found that there are many SGX projects that already utilize libraries from our supply chain. To be noted, we only count mature projects maintained by well-organized developers, as displayed in this table. So we believe that our impact is very solid. So to conclude this talk, I want to emphasize that software supply chain security has become more and more important. We all know about the infamous Heartbleed bug, an example of supply chain failure where a single bug affected 500,000 websites on the earth. So software supply chain security is particularly important to SGX. And in our opinion, it is a key factor that decides whether the adoption of the technology can be successful or not. We hope our work can help with the advancement of trusted computing in protecting people's privacy without compromising the kind of services we can offer them.